let's read the question. It says, what is a units digit of 18 raised to the nth power, or simply 18 up to n? Statement 1 says, when n is divided by 4, the remainder is 3. Statement 2 says, when n is divided by 5, the remainder is 3. Well then, a good strategy is always to try and reformulate the question itself. Let's try to rewrite the question in a simpler way so that we can really understand what is it they're asking. 18 is a number that can be expressed as the product of 6 and 3. And so, 18 up to n is actually the product of 6 up to n times 3 up to n. But let's notice why this factorization of the original power is convenient here. You can see that if you raise a number whose units digit is 6, no matter what is the exponent, provided that it is a positive integer exponent, any power of 6 will always end in digit 6. So this is interesting. We know that this number here will be a number ended always in 6. While 3 up to n is a number that will have a units digit depending on the value of the exponent. But since we are trying to establish the units digit of this quantity, what we really need to know is what is the units digit of this quantity. Once we know that, we can calculate what is the units digit of the product. So the true question is actually what is the last digit of this number, or the units digit of 3 up to n. Okay, we need to realize that the powers of 3 are cyclic regarding the units digit. For example, let's notice that if you raise this up to 1, the number ends in 3, it's actually 3. 3 squared is 9, 3 cubed is 27, notice the last digit 7, and 3 up to 4 equals 81, ends in 1. And so, when you multiply now 81 times 3, that is 3 up to 5, what we'll have is 243, and the cycle repeats again. Considering this, let's analyze statement 1. In statement 1, it says, when n is divided by 4, the remainder is 3. So this exponent can be expressed as the product of divisor 4 multiplied by some integer quotient plus the remainder 3. So if we try to calculate what is the units digit of 3 up to this exponent, we can split exponent n like this using properties of exponents. This is 3 up to 4x times 3 cubed. So basically, since we know what is the units digit of this is already 7, so in order to determine what is the units digit of 3 up to n, all we need to do is to determine what is the units digit of this portion. But notice, according to the property of a power, 3 up to 4 times x can be expressed as 3 up to 4 up to x. And since 3 up to 4 is actually 81, no matter what is exponent x, provided it is a positive integer, 81 up to x will always end in 1. And this part ends in 7, so the product of the two will always end in 7. So now we can give a unique answer to the question, and that is why statement 1 is sufficient. Okay, now let's move on and analyze statement 2. In statement 2, n can be represented as 5 multiplied by some integer quotient x plus the remainder 3. What would happen if x were 1? We would have 5 times 1 plus 3 would be 8. So we would have 3 up to 8. But 3 up to 8 is the same as 3 up to 4 up to 2. In other words, 81 squared ends in 1. So this would be the units digit by which we need to multiply 6 up to n. So we would know what is the units digit of the original expression in the question. Okay, with this case, good. But what about if x were 2, for example? This would be 5 times 2 plus 3. In other words, n would be 13. So we would have 3 up to 13, but this would be the same as 3 up to 12 times 3, and 3 up to 12 is the same as 3 up to 4 up to 3 times 3. So now we know that with a different units digit for 3 up to n, we will have a different units digit for 18 up to n. So statement 2 alone is not sufficient. The correct answer choice would be A. Statement 1 alone is sufficient, but statement 2 alone is not sufficient.